Hey everyone, and welcome back to Talk Tensors. Today, we're going to be taking a look at model alignment search.
Oh, yeah, this is a cool one.
It is a cool one and a really interesting paper.
Yeah.
So this is from the Alignment Research Center,
Mm-hmm.
and it's looking at how we can evaluate whether two neural networks are representing information in the same way.
Yeah, this has been sort of a nagging problem in machine learning for a while now.
Right, like we're always trying to understand
Yeah.
how these things are working.
And what's going on under the hood?
Yeah, exactly.
Yeah.
And I mean, we can compare outputs.
Right, we can look at the outputs and we can tell if two models are getting similar answers.
Right. Are they both good at image classification, or
Right,
are
even
they both good translating languages or whatever? But how do we actually get at
Yeah. How do we know if they're doing it in the same way?
if they're actually representing information in the same way?
So this is a big problem, especially when we're trying to understand how AI relates to human cognition. Because we can't just open up a human brain and see what's going on.
Yeah.
But maybe by understanding how different AI models represent information, we can get some clues.
Yeah, that'd be great.
Yeah.
So they have this new technique that they present in this paper called model alignment search, or MAS.
Yeah. MAS is really cool.
So what is it?
Well, it's kind of like imagine you have two different maps of the same city,
Okay.
right? They might both be accurate.
Yeah.
They might both get you to the same places,
Right.
but they might use different symbols, different colors, different scales.
Yeah.
MAS is kind of like trying to find a way to translate between those two maps.
Okay.
So you can understand how they both represent the same underlying information.
So it's like finding a Rosetta Stone
Exactly.
for these AI models.
Yeah, a Rosetta Stone for AI.
I like
Period.
that.
Yeah.
Okay, cool. So how does it actually work, though?
So basically what MAS does is it tries to find a way to transform the internal representations of one model
Okay.
so that they can be used by the other model.
And this is like actually changing the models themselves.
Right. It's not just comparing them side by side.
Okay.
It's actually trying to manipulate one model
Right.
so that it can use the information from the other model.
Okay, that's interesting.
Yeah. And if it can do that successfully, if it can take information from one model and use it in the other model,
Yeah.
then that suggests that those two models are representing information in a similar way.
So it's like a test
Exactly.
to see how aligned they are. Okay.
Yeah.
And how does this compare to other methods that people have used in the past?
So in the past, people have used things like representational similarity analysis, or RSA,
Right.
which basically just looks for correlations between the activity patterns of different models.
Right. Like if they both light up
Yeah,
when they see a cat.
exactly.
Yeah.
But the problem with RSA is that it doesn't tell you why those models are similar.
Right. It could be a coincidence.
Exactly.
It could just be
Yeah.
happening to have similar patterns for completely different reasons.
Right. So MAS is different because it's actually trying to causally manipulate one model
Yeah.
to see if it can use information from the other model.
So it's not just observing, it's actually intervening.
Exactly. It's a much stronger test of alignment.
Okay, that makes sense.
Mm.
So before we dive into the nitty-gritty of how MAS works and what they found, let's take a step back and look at the history of representational analysis.
Oh, yeah, that's a good idea.
Like, where did this idea of comparing how different models think even come from?
Well, it's a long and fascinating history, actually. It goes all the way back to the early days of AI research.
Really?
Yeah, back when people were first trying to understand how neural networks work. And one of the earliest approaches was to simply analyze the activation patterns of individual neurons.
Oh, so like trying to figure out
Yeah.
what a neuron likes by seeing what makes it fire.
Exactly.
Okay.
But this approach had its limitations because individual neurons can be quite noisy
Right.
and their responses can vary depending on the context.
Yeah.
So researchers started to look at larger groups of neurons and how their activity patterns related to different concepts.
So instead of focusing on individual neurons,
Yeah.
they started to look at the forest rather than the trees.
Exactly.
Oh.
And this led to the development of techniques like RSA.
Right, which we talked about earlier.
Yeah.
Which looks for correlations between the activation patterns of
Yeah.
different models.
But as we said, RSA has its limitations.
Right.
It can't tell us why two models are similar.
Yeah.
And it doesn't involve any kind of causal manipulation.
Okay, so MES is really building on this history of representational analysis.
It's taking it to the next level
Yeah.
by actually trying to manipulate one model to see if it can use information from the other model.
Okay, it's starting to get the big picture here. So now let's dive into what this specific paper actually did.
Okay.
They used MAS to compare different AI models, right?
They did.
Tell us about the experiments and what they discovered.
All right, well, So they focused on numerical cognition in this paper,
Okay.
which might sound kind of basic, but it's actually really important for a lot of AI tasks.
Right. Like, even if a model isn't specifically doing math,
Yeah.
it still needs to understand
Right.
things like quantity and order.
Exactly. Like if you're looking at a picture
Right.
and you see 3 cats and 2 dogs,
Right.
you need to be able to represent those numbers somehow,
Yeah.
even if you're not doing any explicit arithmetic.
Okay. So they trained a bunch of different models on various numerical tasks. Some were trained to count objects, some to do arithmetic,
Yeah.
others to compare the size of numbers. And then they use MAS to see how well these different models could swap information about numbers.
Exactly. And what they found was that models trained on similar tasks, like
Okay.
different types of counting, could swap information pretty easily.
So that makes sense if they're both learning to count.
Right.
Their internal representations of numbers should be pretty aligned.
You would think so, right? But
Right.
here's where it gets interesting. When they tried to swap information between models trained on very different numerical tasks, like counting versus arithmetic,
Yeah.
things got a lot trickier.
So even though both models deal with numbers, the way they represent those numbers internally might be quite different,
It seems like it.
depending on the task they were trained on.
It's kind of like, imagine you have 2 chefs.
Okay.
One who's really good at baking cakes.
Yeah.
And one who's really good at making sushi.
Okay.
They both use knives, right?
Right.
But they use them in very different ways.
Right.
And they have different ideas about what makes a good knife.
Okay, I like that. So it's
Yeah.
like the models have different tools and techniques,
Yeah,
even though they're both working with numbers.
exactly. And that's what MAS allows us to uncover.
Okay.
It goes beyond just looking at whether a model gets the right answer
Yeah.
and actually probes how it's representing the information internally.
This is really interesting stuff. It's like we're starting to get a glimpse into the minds of these AIs.
It is, yeah. It's
Yeah.
pretty mind-blowing.
Yeah. And it's making me rethink how we evaluate AI models. Like, we can't just assume that they're thinking the same way just because their outputs are similar.
Right. We need to look deeper.
We need to use tools like MAS
Exactly.
to really understand what's going on under the hood. Okay, so before we move on to our novel notions section, I want to make sure we've hit all the key takeaways from this paper.
Sounds good.
So first of all, we learned about MAS,
Yeah.
a new technique for determining if 2 AI models are truly thinking alike,
Mm-hmm.
even if they've been trained on different tasks.
And it's a causal approach.
Right.
It actually involves swapping information between the models to see if they can still function correctly.
Right. And what did they find when they applied MAS to these numerical cognition tasks?
Well, they found that even something as basic as counting
Yeah.
can be represented differently
Right.
depending on the model's training.
So one model's 2 might be completely different from another model's 2.
Exactly. And that's a really important insight because it challenges our assumptions about how AI models learn and represent information.
Yeah, like we didn't think of numbers as being these universal concepts.
Right.
But maybe that's not the case
Maybe not for AI.
for AI.
Yeah.
Okay. So that's MAS. And the key findings from this paper. Now it's time for our novel notions segment,
All right, let's get speculative.
where we take the ideas from the paper
Mhm.
and brainstorm some wild but plausible
Yeah.
research directions.
Let's push the boundaries.
Okay, so what's buzzing around in your brain?
Well, this paper got me thinking about what if we could use MAS
Yeah?
to actually merge the knowledge of different AI models?
Oh, wow. So instead of just comparing them, we're talking about creating a kind of super AI
Right, like a Voltron of AI.
that combines the strengths of multiple models.
Yeah, imagine taking a model that's amazing at recognizing images
Yeah.
and merging it with a model that's a master of language.
But we could have an AI that could not only identify objects,
Mm,
but also describe them, tell stories about them,
exactly.
write poems inspired by them.
It would be like a Renaissance AI.
Okay, this is getting me excited. But how would we actually go about doing this?
Well, I think MAS could be a key tool here.
Okay.
We could use it to identify the specific subspaces
Yeah.
within each model that represent the desired knowledge or skills.
Okay.
And then instead of just swapping information,
Yeah.
we could try to integrate those subspaces into a single unified model.
So it's kind of like taking the best parts of each model and Frankensteining them together.
Kind of, but it wouldn't be a simple cut and paste operation.
Right.
We'd need to carefully align the representations and make sure that the merged model could still function coherently.
Okay, so there would be a lot of technical challenges, but also a lot of potential rewards.
Absolutely.
Maybe we can create AI systems that are far more capable, than anything we have today.
Right, and that could have huge implications for everything from scientific discovery to artistic expression.
This is some serious next-level stuff.
Yeah.
But I guess we should also think about the potential downsides.
Oh, yeah, for
Yeah.
sure.
Like, what are the ethical implications of merging AI models?
Well, one big concern is bias.
Right.
If we're combining models that have learned from different data sets,
Yeah.
we need to be very careful about amplifying any existing biases.
Right, because even if the individual models are fair, the merged model could end up being unfair.
Exactly. And then there's the issue of accountability.
Yeah.
If a merged AI makes a mistake, who's responsible?
Right.
Is it the creators of the original models?
Yeah.
Is it the people who merged them?
This is going to be a whole new can of worms. But I think it's important to start thinking about these issues now
Absolutely.
before we get too far down this road.
We need to be proactive
Yeah.
about mitigating the risks of this technology.
Okay, so merging AI models is a super exciting idea. But it comes with a lot of ethical baggage.
Yeah, it's not something to be taken lightly.
All right, well, I think that's a good place to wrap up our novel notions for today.
Yeah, we've covered a lot of ground, from the technical details of MAS to the philosophical implications of merging AI models.
So what's the big takeaway for our listeners? What should they be thinking about after listening to this deep dive?
Well, I think the most important thing is to realize that AI is not a monolithic entity.
Oh.
It's not this all-powerful, all-knowing force.
Right.
It's a collection of tools
Yeah.
and techniques
Yeah.
that are constantly evolving.
And we're still learning how to use them effectively.
Right, and tools like MAS
Yeah.
can help us to better understand those tools.
Okay, so that's the big takeaway. AI is complex,
Mm-hmm.
but we're starting to get a handle on it.
Yeah, we're making progress.
Okay, well, that's all the time we have for today. Thanks for listening to Talk Tensors.
And keep those brains buzzing.
Yeah, so we've talked a lot about the research and some pretty wild possibilities.
We have. It's been a mind-bending journey. But let's bring it back down to earth for a moment.
Okay.
Why should our listeners care about this?
That's the key question, right?
Like, what's the takeaway for someone who's not an AI researcher? Well, I think one of the biggest takeaways is that AI is not magic.
Okay.
It's not this mysterious force that we can't understand.
Right.
It's built on math and code and data,
Yeah.
and tools like MAS can help us to see how it all works.
So it's like we're lifting the curtain
Exactly.
and demystifying AI.
And that's really important because AI is becoming more and more prevalent in our lives.
Right. It's everywhere. From our phones to our cars to our hospitals.
And as AI becomes more powerful,
Yeah.
it's even more important that we understand how it works.
So we can make sure it's used ethically and responsibly.
Exactly.
Okay, so understanding AI is crucial. But this paper also got us thinking about some pretty wild possibilities.
Dude, yeah, like merging AI models.
Right, that's a whole other level of AI engineering.
It is, yeah. It's like building a super AI.
But as we discussed earlier,
Mm-hmm.
that comes with a lot of ethical consideration,
Oh, yeah, for sure.
like bias and accountability.
Right. We need to be very careful
Yeah.
about how we develop and deploy these kinds of technologies.
Okay, so it's a balancing act between the potential benefits of AI
Yep.
and the potential risks.
It's a tightrope walk,
It is.
but it's a walk we have to take.
Right, because AI is here to stay, and it's only going to become more powerful and pervasive.
So we need to be prepared.
We do. All right, well, that's a great note to end on. Thanks for joining us for this deep dive into model alignment search.
It's been a pleasure.
We hope you learned something new and that you're as excited about the future of AI as we are,
Just remember to approach it with caution.
and a critical eye. All right, folks, until next time, keep those brains buzzing.